you guys were all, I'm sure, in your room and in here, y'all were doing some great multiplication work, really good work with multiplying. And so we're going to keep using that multiplying idea to help us with finding area of a composite figure. Okay, so our I can statement for our little teacher table group now is I can use multiplication and addition to find the area of a composite figure. Okay, here, are y'all wondering what this is? Y'all are learning at working to get better at things. Teachers, I'm learning to get better at things too. So this is recording just me. It's looking at me so I can watch it later to learn how to be a better teacher, okay? So you're going to show me you're focusing on me, Kristen, by your eyes being on me. And we're going to kind of just pretend that's invisible. Does everyone need to wave at it a minute to get it out of your system? Wave for a minute. Oh, okay, we see it. Now we're going to ignore it. Just act like it's not there. Okay, so we're going to use multiplication and addition to find the area of a composite figure. So first I'm going to show y'all, I have a composite figure that's, if I have a composite figure, so two figures put together, I'm going to kind of look for where the two rectangles. And then to find the area, I want to be efficient. I want to be an efficient mathematician, and instead of counting, remember area is the space in the middle. Instead of counting, I'm going to multiply. So I'm going to look at this first figure I have. It's 2 units by 1, 2, 3, 4. By 4. So even if I'm tempted to find the area by counting, if I kind of feel safe with that, I'm not going to count. I'm just going to multiply 2 times 4 is 8. And then my other figure over here, 1, 2, 3 units. 3 units by 1, 2, 3, 4, 5. 5 units. Again, I might be tempted to count it to find the area, but I'm not. I'm going to do 3 times 5. 3 times 5 is 15. I'm going to count that just to see. 5, 10, 15. Now, I know if it's the area of the composite figure, it's both figures put together. So instead of counting all that put together, I'm going to be efficient and I'm just going to add my 8 plus 15. 8 plus 15. To do that, I'm actually going to count on. I'm going to put my biggest number first. So I'm going to switch it to 15 plus 8 because I could switch the order. 15, 16, 17, 18, 19, 20, 21, 22, 23. Talk to your partner, why did I switch it to count on starting with my biggest number first? Why did I start counting on with my biggest number first? Why do you count with your biggest number first if you're counting on? Why? Very good, right. So I heard y'all say we want to start with that bigger number to make it a little easier. So we're already starting further along, more than halfway, and then we have fewer numbers to count on. So you guys are going to practice doing the same thing. Each one of you is going to start with just making a shape with an area that's less than 30. After you make the shape, you're going to find the area of your area. So do you all have a pencil you can use? You're welcome. How polite. Do you have a pencil? Oh, here I have one. Here's one.
For double up, we need markers. She's expo markers.
So draw a shape.
Expo markers. Coloring which ones. Okay. Using the squares, right?
Using the squares. Great. We're doing a simple shape, just a rectangle, not a complicated shape, not a composite shape yet. Now find the area using multiplication. Find the area using multiplication. Perfect. Now find the area using multiplication. Great job. Find the area using multiplication. So it's the length of one side by the other side.
Cadence.
Oh,
Cadence.
don't have her go?
No, she can go.
Cadence.
Yeah, you could go. No, she's
You can work with.
Go with Miss Sutherland.
Ian, will you come join me? So how long is that? Right. I want you to draw me a rectangle and then find the area that's using this area formula that you're multiplying by the times the width. Okay, how long is it?
Can I get a dice?
Oh, we're not counting the ones. Just look at how wide is it, how long is it. So how many here? 1, 2, 3. Right? So 3 times 1, 2, 3 times 5, 6, 7. 7, right? Is that a 7? So now you're going to 3 times 7. Okay, ready? Perfect, girls. Excellent job. Now what y'all are going to do, you're going to take your shapes and imagine if you put them together as a composite shape. What would the area be if we put them together? So now you two work together to find that out. You know what? I want you to look at the multiplication chart and I want you to find 3 times 7 on here.
I guess we're going to talk about those meetings.
Do you know how to use that? No? Okay. You're going to find the 7, you'll come down, and then you'll go to where the 3 and the 7 line up. Do you see that? I'm not tall enough to point, so I don't know if I can. So what happens when you line the 3 and the 7 up? What number does that match?
You can still reach.
I know, I'm still too short. So our
Stood on the table
7, we're going to go over to see how it lines up.
So my point is
7 and the 3. What number is that? Perfect.
Voice level.
Here, so we have hers 21, and we're going to pretend that we put everybody together to make a composite shape. And I want you to put three together to figure out what would the area of the composite shape be if you put those two shapes together. What did you guys figure out? How did you solve it? So you girls are telling me you both multiplied to find the area of your own shape. I did not see either one of you count the boxes. You both multiplied. And then, when we made it a composite shape and put it together, you didn't count them up. You just added the two numbers. Super efficient. Super efficient. Now I have a question for you. What if I took this shape and instead of it being added over here like this, what if I moved it here? How would we find it then? What do you think? It's
Voice
the same
level.
number, even if I move it.
Voice
What if I
level.
moved it?
Okay, everybody separate. We're going to go silent for about 5 minutes.
If it stays the same way,
James.
Good job. You could go to stations. Did you guys figure it out?
for you.
I have to do that once a day with this class.
Yes.
5 minutes of silent time.
Why did you just have this? We're finding area, so I thought we were multiplying.
I knew that 20 plus 20 equals 40, and 1 plus 1 equals.
We multiply to find the areas first, but then when we put them together to become a composite shape or something, we just add it. That's awesome. Y'all didn't count it. None of y'all counted. I saw y'all.
They get quiet because they earn letters once they
No, it's not. Here, now,
James.
what if, instead of putting it together as a composite figure this way, what if I like added it and we're shaping it like this? How would I put that out? Does that change the area?
No.
But I changed the shape, guys, so. Are you sure it doesn't change the area?
Change the shape?
I did change the shape, but did it change the area?
No.
Yes, you think yes, defend it.
Because, see, this is one of them. That's another. That was like, just,
Oh, I see you're really pondering this. Okay, so area is the amount of space inside it, right? When I move it different ways, does it change how much of the space is inside it?
no.
You're right, it really doesn't.
Like,
I'm
because
just-
you're just moving the
I'm
shape,
just
you're
moving
not,
it around,
like,
but
you're
I'm not
changing it.
shrinking it or growing it, right? You guys are awesome mathematicians. Thank you. Y'all can go to stations.